Question 4 gives us this inequality. It says half of x minus 4 is going to be greater than 3x. So for this particular inequality, we're actually having to apply algebra sense to be able to figure out what values of x work to make sure that this left side, the left side, will always be greater than the right. And there are infinite values of x, but they have to begin at a certain point and end at a certain, or not end at a certain, but begin at a certain point and go on in order for it to work. So what we're going to do is we're going to apply algebra sense to make sure it works. So what we're first going to do is we're going to get rid of the fraction. So what I'm going to do is I'm going to double this side. I'm going to multiply it by 2, and I'm going to multiply this side. So if half of x minus 4 is greater than 3x, then x minus 4 by itself will be greater than 6x. Okay? And then now that we have variables on both sides, I'm going to create a zero pair by subtracting x from both sides. So if x minus 4 is greater than 6x, then minus 4 is going to be greater than 5x. And if I divide both sides by 5, I end up, oh, that's the wrong variant, hang on. Can I reverse that? If I divide both sides by 5, I get negative 0.8 is greater than x, or negative 4/5. Both are the same. That's just the decimal version. So that's the value of x. And now that I have that, I can then take my number line and put, let's put negative 1, 0, and 1. And negative 0.8 is right around here, but it doesn't include negative 0.8. But all numbers, oh, I read that wrong, didn't I? Oopsie daisy. Remember, we read it from our variable this way. So it says x is less than negative 0.8. So less than is going to start at 0.8, and all numbers less than that, it's going to include all of those numbers. So that's the solution to the inequality.